So this is going to be chapter 13, help for you for this week's content. And I'm going to do a couple of problems that, to start off, first one on page 222. I'll try to give you some examples of all the questions in this chapter. So, chapter 22, let's do, or 222, let's do, let's do number 5. So on this question, it tells us in the instructions to calculate the milliliters per hour. For these continuous infusions, round the answers to the nearest whole number. And so number 5 would be infuse D5W 0.9% sodium chloride solution, 750 milliliters, over 5 hours. And again, we're solving for milliliters per hour. So with dimensional analysis, always start with milliliters on top, because that's what it tells us to do right there. So we're going to plug in our information, 750 milliliters over 5 hours. And that's where we need to end up with. So ultimately, you're just doing that division. 750 divided by 5 gives us 150 milliliters per hour. Now let's move to page 224 in your book. And let's look at doing an example of these. So let's do number 5 for this one as well. So number 5, it tells us in the instructions to calculate the milliliters per hour. And round to the whole number. So number 5 tells us to infuse penicillin G 5 million units. So 5, 1, 2, 3, 4, 5, 6 units of penicillin G diluted in 100 milliliters. And that needs to infuse over 30 minutes. And again, we're solving for milliliters per hour. So I know I need to start my problem off with milliliters. So I'll look in my information here, and there's our milliliters. And since this is dealing with time here, because we know that's what we're solving for, I need to look for some other information in my question that has to do with time. And so the 30 minutes there is what we have that is in relation to time. This becomes not needed in this question because ultimately that 5 million units is already in this 100 milliliters, so that is just fluff in this question. So of this, we have minutes here and we need to go to hours. So if this is minutes, we have to have minutes here, and I know I need to go to hours, so I go to my known variables. I know that there are 60 minutes in 1 hour, and then your minutes would cancel out. So 100 times 60 gives us 6,000 over 30 times 1, and that gives us 200 milliliters per hour.